We didn't get to go over the 1.5 lessons very well, so I'd like to do a little bit just as a tutorial. So the first day demonstration, that's when we were doing the penny in the nitric acid, and we read the little story about nitric acid acts on copper. So observations before we started then, so we had a penny, and we had, which we know we say observation was that it's copper colored and it's a metal, and then we had a clear liquid, which was our nitric acid. And we can write that down. Copper we know is Cu, nitric acid, HNO3. Then afterwards there was a nice red-brown gas, and then when the water came back in, there was a pretty peacock blue solution. So the gas was NO2 gas, and the peacock blue solution was the copper ion. Now the reaction itself, okay, it looks like this guy down here. Now this is not the way we did it. We did it in a Florence flask. But initially, then you got all this foamy stuff, and it was very dark. But when the water came back in later, we had a really pretty peacock blue solution. We were making a gas up here, and we know that that gas, I believe, is actually NO, but when it mixes with the oxygen and the air, it turns into NO2. So the NO2 gas is the reddish-brown toxic gas. So what it's having is that the element copper is oxidized, okay, from 0, the metal, to the +2 ion. And then the element nitrogen, okay, in the HNO3, then the nitrogen is changing from N here to the N here. Okay, this one would be in a +5 oxidation state if you stop and figure that out. And oxygen's being -2, this way it would be in the +4 oxidation state. So it's going 5 to 4. So whoever gets oxidized is called the reducing agent, and whoever is reduced is called the oxidizing agent. So the nitric acid, the N in the nitric is changing from 5 down to 4. So we would say that it's getting reduced, so it is the oxidizing agent. And the agent is always the full molecule, not just the N. The N gets reduced, but the whole chemical, the nitric acid, is the oxidizing agent. And in the same way here, the copper, it's getting oxidized from 0 to 2+, so it's the reducing agent. So oxidizing, reducing agent. Whoever gets oxidized is the reducing agent. Whoever gets reduced is the oxidizing agent. Okay, nitric acid is a very good oxidizing agent. In fact, it's an oxidizing acid. And we're going to find there's only 2 good oxidizing acids, nitric acid and sulfuric acid. And other things to kind of tuck away in your brain, metals are always good reducing agents. Metals are reducing agents, not always good, because they always turn into positive ions. So they always get oxidized so they can reduce other things with it. Now, we had examples here. So the first example was aluminum and copper ion turned into copper and aluminum ion. And the reason we had this one was that it's actually, you could go ahead and balance this, just straightforward. You say, here's copper and copper, aluminum and aluminum. The atoms are balanced, but the charges are not. So it's not a big surprise that all we have to do is say, well, 2 and 3, we need to make 3 coppers, and we need to have 2 aluminums, and that balances our equation. So that balances the charge 6+ on each side. Now the next one down here, though, that's a bigger story. So what we have is we're going to do half reaction method. We're going to start off and say, okay, I have copper on one side turning into copper 2+. So we just look at a reaction and say who's changing, and if you have a neutral element, then you know that that's part of our reaction. So copper to copper 2+, that's one change. Okay, the other change, we have nitric acid, and we're going to say it turns into NO. Now, if it's not obvious what's going on, you really can go back and figure out everybody's oxidation number and see how they change, and whoever is changing, that's the one you want. So I'm going to say HNO3, and I'm going to say that changes into NO. Okay, we're not worried about the water at all because that's going to come out in a few minutes. So going back here, we'll go back to the first half reaction, and each of these are called half reactions because only one element is changing, so we're getting an oxidation in one case and a reduction in another case. So here we have our coppers. Okay, what we want to do is to get everybody to balance who's not hydrogen and oxygen. Well, since it's only copper, then that's balanced already, 1 and 1. And we don't have to worry about oxygens, don't have to worry about hydrogens. All we have to worry about is the charge. So we say which side is more positive, the one on the right. It's more positive by 2, so we put in 2 electrons. So now the right side is neutral, the left side is neutral, they are balanced. Now they don't have to be neutral on both sides, they just have to be balanced, and they're both balanced in this case. Okay, now we go to our other reaction. Okay, we have nitrogens. So here's one nitrogen, here's one nitrogen. Okay, that's balanced. That's the first step. Anything besides oxygens and hydrogens. Next step is oxygens. Here's 3 oxygens, here's 1 oxygen. So we're going to need 2 more oxygens. So we throw in 2 water molecules. Okay, I can't just throw in O2s because they're not sitting around in reactions in solution all the time. But there certainly is water there. So now we have 3 and 3. We're good on the oxygens. Hydrogens. This side we have 1. This side we have 2 times 2, 4. So I need 3 more hydrogens on the left side. And I can put those in as hydrogen ions. Because we learned that, when we learned about the Z diagram, every solution has hydrogen ions and hydroxide ions. Anything that has water in it has hydrogens and hydroxides of different amounts. So if we need a hydrogen ion, we can just throw it in, and we just did. Now the last step is the charge. So look at both sides. The left side is more positive than the right side. It's more positive by 3, so I'm going to add 3 negative electrons. Now I want to balance these two, so everything on the left turns into everything on the right. And you can see what's going to happen is I need to get my electrons to cancel. And if I have 2 electrons and 3 electrons, I can get that to work if I multiply the whole top reaction by 3. So that'll make this a 6, put a 3 and a 3, and make the whole bottom multiply by 2. That'll make this a 6. That'll make this a 6, 2, 2, and 2. We already had 2, so make that a 4, sorry. And now we put those 2 equations together. And I'll do it here. So we're going to cancel out the 6 electrons. And that's the only thing that cancels. So my final reaction is 6 H pluses plus 3 coppers plus 2 HNO3s turns into 3 copper ions and 2 NOs and 4 H2Os. And that's the final balanced equation. Okay, next example. We have permanganate plus peroxide turns into manganese ion and oxygen. So I can see, well, I have oxygen, so I know that's part of my reaction. And what have I got? I've got permanganate and I've got peroxide. So I'm going to say my peroxide turns into my O2. So that's one of my reactions. Okay, on the other side I have permanganate, MnO4. Oops. And I'm going to have that change into Mn2+. So those are my beginning of the 2 reactions. Okay, let's go back and do the peroxide. Okay, I've got, all I have are oxygens and hydrogens. So I'm going to do my oxygens, they're balanced. Hydrogens, I need to add 2 H pluses. And the right side is more positive by 2, so I'm putting in 2 electrons. Okay, for here I have manganese and manganese, I'm good there. 4 oxygens, so I'm going to add 4 water molecules on the right side. And that means I need to put on 8 hydrogens on the left side. And now I look at this and I say, okay, I've got charges. I've got +7 on the left and I've got +2 on the right. The left is more positive by 5, so I'm going to add 5 electrons. I'm just going to tuck them in here. And I want to put these 2 together. So I have 2 electrons and 5 electrons, so I'll multiply the top by 5. So I'm going to have 10 electrons. I'm going to have 10 H pluses, 5 and 5. Multiply the bottom reaction by 2. So I have 16, 2, 10, 2, and 8. And now we can go back and cancel. So I know my 10 electrons are going to cancel. And I have 10 hydrogens on the right side of here. I have 16 here, so these 10 will go, and this will change to a 6. And there's nothing else that is common on both sides, so I'll just recopy my problem here. So I have 6 H pluses. Oops, too far down. Okay, 6 H pluses plus I have 2 permanganates, and I have 5 H2O2s, and on the right side I have 2 manganese, and I have 5 O2s, and I have 8 H2Os. And that's my balanced equation. Let me double check my charges. On the right side I have 2 times 2, I have 4 plus. On the left side I have 2 times minus 1, that's minus 2, well I have 6 hydrogens. So 6 plus minus 2 is 4 plus. 4 plus on both sides, so I think that's my balanced equation. Now this last one down here, we'll start over. Okay, I have chlorine changing into chloride, and I can say chlorine changes into hypochlorite. So I have the same element being both oxidized and reduced. So what's going to happen? First one here, I need to put a 2 in front of my chlorines. Okay, that's all my elements. I need to balance my charges. The left side is more positive by 2, so I'm going to give 2 electrons. So that top reaction is balanced. The bottom one, I need to put 2, so I have 2 chlorines. Now I'll do my oxygens. I have 2 oxygens on the left, so I'm going to throw 2 waters. I said that wrong. 2 oxygens on the right, so I'm going to put 2 waters on the left. Now I have 4 hydrogens on the left. I'm going to add 4 H pluses on the right. And my right side has a charge of, here's 2 minus and 4 plus, so I'm going to make that a 2 plus. So I'm going to add 2 electrons, because the right side is more positive by 2. So now I put them together. Okay, I have 2 electrons, so that cancels. And that's the only thing that cancels out. Everything else is just going to add up. So what do I have? I have 2 chlorines, and, okay, I'll write it down here, 2 chlorines, and I have 2 H2Os, turns into 2 Cl minuses, 2 hypochlorites, and 4 hydrogen ions. Now, because this is an alkaline solution, I have one more step, and that is I cannot have hydroxides, I cannot have hydrogen ions in a solution of basic, a basic or alkaline solution. They're going to add 4 OH minuses to both sides. And these are going to turn into 4 waters. And when I'm done, I have 4 waters, I have 2 waters, so that's going to change this to a 2. So my final reaction is 2 Cl2s plus 4 OH minuses turn into 2 Cl minuses, 2 ClO minuses, and 2 water molecules. And that's my final balanced equation, except everything is 2's. So I'm going to reduce. So Cl plus 2 OH minuses turn into Cl minus plus ClO minus plus H2O. That'll be my balanced equation. And there's a name when the same chemical is both oxidized and reduced, and that name is called disproportionation. So I've seen that on the AP test before. In the disproportionation reaction of chlorine, blah, blah, blah occurs. And that's one of the ideas. So that is the notes for the, oh, we have one more. Okay, then it says at the end here, okay, here are some common oxidizing and reducing agents. Okay, and we can see the oxidizing agents are things that have lots of oxygens on it, chromates and permanganates and sulfates and nitrates. Those are common. And then we have some common reducing. We said metals. Okay, metals can turn into metal ions and things. So that's what we're going to do. So let's say we had some sulfuric acid. And I'm sorry, not that. I'm going to do the halides here. Okay, sulfuric acid, and let's say I mix it with some chloride. Okay, like hydrogen chloride, hydrochloric acid. Then what's going to happen? My sulfuric acid is going to turn into SO2 and water, but we'll put that in later. And the chloride is going to turn into chlorine. So part of my reaction is going to be H2SO4 turns into SO2. Now here are S's and S's, those are taken care of. I have 4 O's and 2 O's, so I'm going to add 2 waters over here. That gives me 4 hydrogens on the right, 2 hydrogens on the left, so I'm going to add 2 more hydrogens. And to make sure that everything balances, I'm going to add 2 electrons. Okay, so now both sides are electrically neutral. Okay, on the other one here I have chloride, Cl minus, turning into Cl2. I need 2 chlorides, and there are no oxygens or hydrogens, so which side is more positive? The right side, more positive by 2, so that's my balanced half reaction. I'm going to put these two together. Oops, these two together. So I have 2 electrons and 2 electrons, they cancel, so that's easy. And that's the only thing that cancels. So my final reaction is going to be H2SO4 plus 2 H pluses plus Cl minuses, 2 Cl minuses, turns into SO2, Cl2, 2 H2Os. And I cannot reduce, so this is my final reaction. Now we're done.